In the last section, we looked at classifying organic molecules. Specifically, we classified alcohols as primary alcohols, secondary alcohols, and tertiary alcohols. And then I mentioned that the purpose of this classification was to help in the appreciation of organic reaction mechanisms. And today, we look at the oxidation of alcohols, and I have here a primary alcohol, ethanol, with the OH group attached to carbon 1 and 2 hydrogens attached to this carbon, making this a primary alcohol. When this alcohol undergoes oxidation, we need to introduce an oxidizing agent, like acidified potassium dichromate, into the reaction vessel. But organic reactions don't just happen instantaneously. They need significant inputs of energy and long times of boiling under a process known as reflux. And here's a look at a reflux apparatus. So when this primary alcohol is boiled under reflux for several hours, then the first product is this one, where hydrogens are removed and then oxidation occurs by dehydrogenation or the removal of hydrogen. And the product is ethanal, with the prefix eth being used because you have 2 carbons, but this functional group being the outcome, this the aldehyde functional group, and this product ethanal. But if you continue to boil under reflux for even longer, then further oxidation happens, and the ethanal then becomes ethanoic acid. Again, the prefix eth, because there are 2 carbons, and this, the carboxylic acid functional group. The carboxylic acid functional group is capable of forming hydrogen bonds to other carboxylic acids, giving this carboxylic acid a very high boiling point compared to ethanal, which does not form hydrogen bonds but has weaker intermolecular forces. And this important difference between the end product, the carboxylic acid, and the intermediate product, ethanal, allows us to separate the 2 products by the process of distillation. Let's take a look at this distillation setup. But in the last section, we distinguished between primary alcohols and secondary alcohols. What about if an alcohol is a secondary alcohol? When you apply an oxidizing agent to a secondary alcohol, this OH group undergoes oxidation. And it leads to the formation of a double bond, O, and then this hydrogen is removed. Because carbon can only form 4 bonds, 2 hydrogens removed. It's an oxidation again by dehydrogenation, and these 2 groups, these 2 methyl groups, which can generally be referred to as an R group or an alkyl group, which can have the formula CnH2n plus 1. So you can have groups like CH3, C2H5, C3H7, and in general we refer to this as an R group. So here you can see one R group here, another R group here, attached to this ketone functional group, C double bond O. But the question is, could this alcohol possibly go on to get further oxidized to form a carboxylic acid? Is it possible to attach an OH, just like in the case of ethanoic acid? But where would this OH go? In the case of ethanal, it took the place of a hydrogen, with an oxygen being added to that hydrogen. But here in this ketone, there are no hydrogens attached to this carbon, making this ketone the end product of secondary alcohol oxidation. And what about the tertiary alcohol? Do you recall the structure of a tertiary alcohol? Think about if it's possible for the tertiary alcohol to undergo any kind of oxidation. And here you can see a drawing of a tertiary alcohol with this being an R group, that being an R group, and that being an R group, and here you have the alcohol functional group. If oxidation is to occur by dehydrogenation like it did in a primary alcohol, then 2 H's would have to be removed. But here, the possibility of removing this H might exist, but where would the second H come from? And therefore, the primary alcohol can undergo first an oxidation to an aldehyde and then to a carboxylic acid. The secondary alcohol is limited and is only able to get oxidized to a ketone. And the tertiary alcohol cannot be oxidized.